What's up friends, इस वीडियो में we will be doing objective 1 from HC Verma and the chapter will be kinematics, rest and motion. Let's start with the first question. A motor car is going to north with a speed of 50 kmph. It makes 90 turn towards left or without changing its speed. आपको बताना है change in velocity of the car. Okay, so some people think 0 because but the answer will not be 0 because it is changing its direction, so velocity must change. Okay, you have to do it vectorially. Let's say change in velocity is always defined as vf minus vi, final velocity minus initial velocity. It is moving towards north and then take a left turn. Okay, so this is the final velocity, this is the initial velocity, and we have to subtract final and minus initial. Initial is towards north, so minus initial will be towards just opposite to north south. Okay, so we have to take now the resultant of these two vectors, which is vf and minus vi. Okay, so it will be 50 root 2. You must know that how to resolve or take the resultant of two vectors. So we get 50 root 2, which is almost 70 towards southwest direction. Okay, question is very easy. It is showing a graph of displacement versus time for a particle. आपको बताना है which of the following is correct. So from the graph we can deduce that it is moving with uniform velocity till t naught, and then it comes to rest. Okay, because its position is not changing. So initial velocity is uniform up to t naught, and then it's become 0. So we should go, the particle moves at a constant velocity up to t naught, then stops. Option D. Okay, let's talk about the third question. A particle has a velocity u towards east at t equal to 0. Its acceleration is towards west and is constant. Let x say x be the magnitude of displacement in the first 10 seconds and the next 10 seconds. आपको बताना है which one will be more or less, or whether the data is insufficient to reduce anything. Okay, this is a very good question. Let's look at the solution. Basically क्या है, यहाँ पर आपको ये दे रखा है that particle is retarding initially. So let's say it start with t equal to 0 towards this direction, towards right, and the acceleration is towards left. So it might be the case that first 20 seconds is before stopping. Okay, I'm saying that it takes 20 seconds to stop, more than 20 seconds to stop. So it will be moving xa, this red xa in the first 10 second, and then with red xb in the next 10 second, because it is retarding, okay, throughout the motion. So xa will be greater than xb. The next case can be that it exactly stops at t equal to 10. Okay, if it stops at t equal to 10, then in the first 10 seconds this motion will be green or blue xa, this one. Similarly, in the next 10 seconds it will move equal displacement, just in opposite direction, because acceleration is constant. Okay, so in this case, if it stops at t equal to 10, or it reaches at this point at t equal to 10, these two displacements will be equal. So the third case can be that it reaches till this point, it reaches till this point, point number 5, in first 10 seconds, and then in the next 10 seconds obviously it will move to a farther point 6, because from 5 to 6 it is continuously speeding up, but from t equal to 0 to 5 it will be uh, slowing down till 3 and then speeding up. So xa will be smaller than xb. Okay, so we cannot find which option we can take. So option D, that the data is insufficient, should be the answer. एक बार आप दोबारा देख सकते हैं. बेसिकली क्या है कि अगर वो उसका पाथ तो हमने दिखा दिया कि वो थोड़ा आगे जाएगा और फिर वो वापस टर्न लेगा. अगर उसको रुकने में 20 सेकंड से ज़्यादा लगते हैं तो ऑब्वियसली एक्स ए और एक्स बी कुछ ऐसे होंगे, पहले 10 सेकंड, बाद के 10 सेकंड, एंड सम मोर टाइम टू स्टॉप. सो एक्स ए विल बी ग्रेटर। अगर उसको स्टॉप करने में एग्जैक्टली 10 सेकेंड लगते हैं तो एक्स ए एंड एक्स बी विल बी इक्वल। अगर वो 10 सेकेंड से पहले ही स्टॉप हो जाता है तो 10 सेकेंड के बाद वो यहाँ पर होगा। सो एक्स ए विल बी स्मॉलर देन एक्स बी। ओके। Fourth question is an easy one. A person is traveling on a straight line with uniform velocity v1 for some time. Then for equal interval of time v2, the average velocity will be v1 plus v2 by 2. You can simply solve this using that the first displacement is s1, which will be v1t, s2 v2t. V average is total displacement by total time. Total displacement will be the sum of these two displacements and total time is 2t. So we'll get V average as v1 plus v2 by 2. The next question is slightly tricky. Now the particle is moving with velocity v1 and v2, but for the equal distances. Okay, so we have to find the average velocity. In that case, we can say let if it moves at x distance with velocity v1, so time taken will be t1 is equal to x by v1. Similarly, if it moves further x with velocity v2, time taken will be t2. Average speed is total distance by total time. We will find out total distance is x plus x, which is time is x by v1, x by v2. We will take the ratio, we will get as this. Okay, so V average can be written as this, or there is a simple formula 2v1 v2 over v1 plus v2. And the next question, a stone is released from an elevator which is going up with an acceleration a. We have to find the acceleration of stone. The acceleration of stone will be g downwards, as the only force acting on the stone after it is released is mg. So its acceleration with respect to ground will be g, but its acceleration with respect to lift will be acceleration of stone minus acceleration of lift. Acceleration of stone is g downward minus acceleration of lift is upward. So acceleration of stone with respect to lift will be g plus a downward, but it is not asked. Okay, so the acceleration of stone will be simply g downwards. Okay. In the next question, there's a person standing near the edge of a top of a building, throws two balls with equal speed but in opposite direction, one upward, one downward, and they hit the ground with speed va and vb. So they will be equal. We can prove that using third equation. Displacement is same initial velocity का magnitude, so v square equal to u square plus 2s. Acceleration is also same, so u is same, in fact u square is same. 2 and a and s both are same, so v will be same. We can also prove this by a conservation of energy. Both loses same amount of potential energy, so they will gain same amount of kinetic energy. In a projectile motion, the velocity is perpendicular to acceleration for only one instant when it is at the top, and y direction velocity is 0. So in this projectile, velocity and acceleration are perpendicular only at this point. Okay. Two bullets are fired simultaneously horizontally with different speeds from the same place. Which bullet will hit the ground first? Obviously, both will reach the ground simultaneously because they will have same parameters in y direction. Okay, let's say this has high velocity in x, this has low velocity in x, but in y they have same zero velocity. They have to move same displacement in y direction. Their acceleration in y direction is also same, so the time taken will also be same. I have taken one more additional case in which the bullet is just dropped at the same time. In this case also, in all three cases, time taken will be same. In the next question, range of a projectile fired at 15 degrees 50 meter. We have to find the range when it is fired with same speed at 45 degrees. So we can go by this calculation. R is u square sine 2 theta by g. Putting the angle as 15 degree, we get this. R1 is given as 50. So when we'll take sine 30 here, we get 100 here, and here we'll be left with u square by g, which is same as u square sine 2 into theta, which is 45 in the next case, which is u square by g. So we get the value of u square by g as 100. In the next question, the range, there's two projectiles A and B are projected with angle 15 and 45, and RA, RB are their range. Then we have to compare which one is more or less, but no other information is given, their speeds. So just by knowing the angle of projection, we cannot comment anything. So the data is insufficient to get any relation between RA and RB. In the next question, a river is flowing from west to east at speed of 5 meter per minute. A man on the south bank, and he is capable of swimming at 10 meter per minute in still water, wants to swim across the river in the shortest time. He should swim in the direction. Obviously, to swim or to cross the river in shortest time, he should start swimming perpendicular to the river flow. Okay, the time will be least, but there will be drift in that case. You can look at the diagram here. X direction is positive. X is the direction of velocity of river. The swimmer should aim in this direction, but he will reach somewhere here, which is the resultant of swimmer with respect to river and river. So but he should aim, or he should try to swim in this direction. So for minimum time, VSR, velocity of swimmer with respect to river, or the direction in which he should try to swim, should be perpendicular to VR, and the minimum time is V width by velocity of swimmer with respect to river. This is given to you. Okay, for further clarification, you can watch my video in which I have explained this concept river board problems. In this last question, we have to find the velocity of this mass if these two ends are pulled with a speed u in downward direction. So this is basically a question from constraint motion, in which the component of velocities along the string, component of velocities along the strings must be same. So we can look at this point. Let's say this is point number 1 and this is point number 2. It has velocity v and it has velocity u. If we'll take the component of this v along the string, that will be v cos theta, and u is completely along the string itself. So we will have v cos theta equal to u. So v will be equal to u cos theta. Okay, the same relation we can get from here. So 2 should not be involved in this. Okay, from this portion we'll write another constraint, for this portion we'll write another constraint. So it will be single v only, not 2v. Okay, so again the component of velocities along the string must be same. Okay, thank you.